The 12th question. Sliding contact of a potentiometer is in the middle of the potentiometer wire having resistance Rp, okay, is equal to 1 ohm as shown in the figure. Okay, an external resistance of Re is equal to 2 ohm is connected via the sliding. Then options are given. Okay, the question is not asked directly. Based on the options only, you should come to conclusion what is asking. Find the total current in the circuit, because all options are given in ampere. Ampere means unit of current. So in this question, finally he is asking what is the current in the circuit, while the circuit of a potentiometer given like this. Okay, you know what is a potentiometer? Potentiometer is a device, isn't it? Potentiometer is a device used to compare EMF of two cells. Okay, that is the main theme, okay, of a potentiometer. So what is the working principle? The potential difference across any two ends or any 2 points of a potentiometer wire is always directly proportional to length of that wire. That means while we are going along the length of a potentiometer wire, potential is gradually dropped, decreases. Okay, so that is the potentiometer principle. Recall what? EMF is directly proportional to what? L. That means potential drop across the length of a potentiometer wire is directly proportional to its length. Okay, right. Now come to the question. Sliding contact. You know, in a potentiometer wire, you want to calculate EMF of a cell. The jockey, that is called as a sliding contact, which is gradually moved from one end of the potentiometer wire until galvanometer, which is connected in the secondary circuit, is shown 0. That means you get the balancing condition. That means while the jockey is where you get on the potentiometer wire, galvanometer shown reading is 0. That means the potential drop across the ends of that wire is balances EMF of a cell, isn't it? Now here, sliding contact of a potentiometer wire is in the middle of the potentiometer wire. That means what is the resistance of this potentiometer wire? 1 ohm. Exactly the jockey, that means sliding contact is kept at center, means you get the balancing condition. That means from this point to center point, resistance is equal to 0.5 ohm. From that center point to another end is also equal to what? 1 ohm. So sorry, 0.5 ohm. Then which is equal to what? 1 ohm. So this is the equation, this is the circuit is redraw like this. What is that? This is a potential, this is the battery of 0.9 volt. Okay, the potential, the sliding contact of a potentiometer wire is gradually moving. Okay, at its center, total resistance is equal to 1 ohm. Center means what? From this point to this point, what is the resistance of this wire? 0.5 ohm. From this center point to remaining, 0.5 ohm. Okay, now what happened? An external resistance of Re, which is connected like this. This is what? 2.2 ohm. This is connected parallel. So what is the current in the circuit? To see, while seeing, redraw this circuit like this, you get one combination. What is that? 0.5 and 2 ohm are in parallel. Okay, so this parallel is in series with 0.5. So that gives rise to total resistance in the circuit. Then already voltage of a battery is given. Then I is equal to V by R. You get the current value. Now we can do it. Okay, right. So what is the resistance of parallel? Rp. That means total resistance. Okay, these two are in parallel. This is in series. So total resistance is equal to what? 0.5 into 2. These two are in parallel. That means what? When parallel combination, what about Rp is equal to what? 1 by R1 plus 1 by R2. That means what is that? Rp is equal to R1 R2 by R1 plus R2. This is the resultant of parallel resistance of this combination, which is in series with 0.5. That means R1 is equal to 0.5, R2 is equal to 2. That means 0.2 into 2 by 0.5 plus 2 plus 0.5, which is this total in series with this one. So total resistance equal to this one. What you get? 0.2 into 1 by 2.5 plus 0.5. Okay, you get 2.5 is LCM, 1 plus 120. That means 1.25. 2.25 by 2.5. Isn't it? 2.25 by 2.5. This is the RP value. Okay, so current, net current in the circuit. Net current I is equal to what? V by R net, or net. P is equal to what? 0.9 by P is equal to 0.9 is given. R net is equal to 2.25 by 2.5. So 0.9 into 2.5 by 2.25. While doing, you get the value of current is equal to approximately 9.2 is equal to what? 2.25 by 2.25 is equal to what? 1 amp. 1 amp. This is the solution for this question. Okay, thank you. The 14th question. A closed argon and open argon tube filled by two different gases having same bulk modulus but different densities ρ1 and ρ2 respectively. The frequency of ninth harmonic of closed tube is identical with the fourth harmonic of open tube. If the length of closed tube is 10 cm and the density ratio of the gases is ρ1 is to ρ2 is equal to 1 is to 16, then the length of the open tube is, to see, a closed argon and an open argon. You know what is a closed argon pipe? If two ends, okay, in the two ends, if one end is closed, one end is open. This is called as a open closed argon pipe. While two ends are open, this is as, what is that? Open argon pipe. So what is this? Is a closed argon pipe. This is open argon pipe. Okay, having, which is filled with two different gases having same bulk modulus. So what is the bulk modulus of a gas filled in closed tube? B1 is equal to B. The bulk modulus of gas filled in open tube, B2 is equal to what? B. Same. Okay, but different densities. The density of a gas filled in closed argon pipe is ρ1 is equal to ρ. Okay, in open argon pipe, density of a gas is ρ2 is equal to what? ρ2. Both are different. ρ1 is equal to ρ1, ρ2 is equal to what? ρ2. Okay, right. Next, what happened? The frequency of ninth harmonic of closed tube. Here what happened? Ninth harmonic. That means at ninth harmonic, what is the operating frequency? Nu 9 is equal to 9 into V by 4L1. V by 4L1. Why? Because in closed argon pipe only odd harmonic are formed. Okay. But in open argon pipe, all harmonics are present. Okay. What is it? The frequency of ninth harmonic of closed tube is identical with fourth harmonic in open tube. What is the at fourth harmonic in open tube? At fourth harmonic, frequency nu 4 is equal to what? 4 into V by 2L. The length of this open pipe is equal to L2. So what is it? V by 2L. Both are identical. That means what? Nu 9 is equal to what? Nu 4. That implies 9 by 4 L1 into V1 is equal to 4 by 2 L2 into V2. Isn't it? Okay, right. Moreover, what is the velocity of a gas in a closed pipe? What is the formula of velocity of a gas in terms of bulk modulus and density? We know velocity of a gas is equal to what? Modulus of velocity, that is called bulk modulus by density of a gas. V by P is equal to root over bulk modulus by density rho. So this equation slightly modified as, therefore 9 by 4 L1. Next, what is given? This is given here. Until this is given. Okay, right. Next, what happened? If the length of the closed tube is, the length of the closed tube L1 is equal to what? 10 centimeter. It is equal to what? 10 centimeter. Okay, and more densities ratio, ρ1 is to ρ2 is given. ρ1 is to ρ2 is equal to what? 1 is to 16. 1 is to 16. Then the length of the open tube is, what is the length of the open tube? It is called L2 is equal to what? Question mark. This is supposed to be calculated. L2 is equal to what? Okay, to calculate L2, you can use this. Okay, what is that? Ninth harmonic in closed tube is equal to identically with the fourth harmonic in open tube. You can use this one. So you can substitute V is equal to B by rho. Therefore, what happened? Therefore, we can write 9 by 4 L1. L1 is equal to 10 centimeter, 9 into 9 by 4 into 10 into V is equal to what? Root over B1 by rho 1 is equal to 200 to 2, that means 2 by L2. 200 to 2 by L2 into V2. V2 is equal to what? V2 by rho 2. That means velocity of gas in open pipe. Okay, right. But B1 is equal to B, B2 is also equal to B. That means it may write 9 by 40 root B by root rho 1. Simplify 2 by L2 into root B by root rho 2. PB cancel. Why? Because both the gas having same bulk more or less. So B1 is equal to B, B2 is also equal to B. So remaining these two also brought it to the side. 9 by 80 it is equal to L2 is equal to, this go to the numerator, means root over rho 1 by rho 2. Rho 1 is given, rho 1 rho 2 is given, what is it? 1 is to 16. Therefore 9 into L2 by 80 is equal to what? 1 by 16, which is implies 9 L2 by 80 is equal to what? 1 by 4. 4 1 ja 420. Therefore L2 is equal to what? 220 by 9 centimeter. That's it. The 14th question, the work functions of cesium and lithium metals are 1.9 electron volt and 2.5 electron volt respectively. If we incident a light of wavelength 550 nanometer on these two metal surfaces, then photoelectric effect is possible for the case of. To see the work function for cesium, suppose this is a cesium metal. Okay, on this cesium metal you are allowed to incident a radiation of sufficient frequency or wavelength, that is called threshold wavelength or threshold frequency. Then what happened? Photoelectrons are ejected from this metal surface. This phenomenon is called photoelectric effect. Okay, according to given question, this is a cesium metal. On this cesium metal, a radiation of energy 1.9 and above, then only photoelectrons are ejected. Similarly, for a lithium metal, okay, the instant radiation of energy, what is the 2.5 electron volt. Okay, on this cesium metal surface, a radiation of minimum energy equal or more than 2.5 electron volt, then only photoelectrons are ejected. This is the statement. Okay, but here what we can say, if we incident a light of wavelength 550 nanometer, that means you are allowed to incident individually or separately on these two metal plates, okay, of a wavelength, what is that? 550, lambda is equal to what? 550 nanometer. Okay, then photoelectrons are ejected either from cesium or lithium or both. This is asking. Okay, you have a direct formula for this question. The work function in terms of electron volt, what is that? 12,400 by lambda electron volt. Okay, how we get, we can discuss later, no problem. To say therefore work function, what is that? 12,400 by lambda. Lambda is given what? 550 nanometer. Okay, then you get what is the value? 550 2 times 550 2 times is equal to 1100. 2 point. Again, that means 124. That means again 2.2, approx 2.2 electron volt. This is the answer. Okay, that means the radiation having energy, instant radiation having energy equal or about 2.2 electron volt, then only photoelectrons are ejected. So here to see in cesium, what is the minimum energy required? The minimum energy of instant radiation equal or above 1.9, then only photoelectrons are ejected. So it is possible. That means from cesium metal, if a radiation of wavelength 550 nanometer is capable to eject the photoelectrons, okay, it is sufficient. But for lithium, the instant radiation must at least equal 2.5 or more than, then only photoelectrons are ejected. So that same 550 nanometer of instant radiation is allowed to incident on lithium, there is no photoelectric effect is ejected. So in the given question, this is the solution. That means from cesium metal only, okay, eject the photoelectrons, okay, while a radiation of frequency or wavelength 550 nanometer is allowed to incident. So this is the answer. What is that? Only from cesium metal photoelectrons are ejected. But here I would like to explain why you get this W is equal to work function is equal to 12,400 electron volt by wavelength, which is obtained from your previous knowledge. What is that? You know, E is equal to h nu. This is the work function actually. From Einstein's photoelectric equation, E is equal to what? H nu plus K max. Okay, kinetic energy maximum. Here h nu naught is called the work function. H nu is equal to what? Work function. So work function is equal to what? H nu naught. So here in terms of wavelength, it may write hc by lambda naught. Here h is equal to what? Planck's constant 6.62 into 10 power minus 38, isn't it, into c, speed of light 3 into 10 power 8 meter per second. Okay, by wavelength. This must be in angstrom. Okay, that means lambda or nanometer, it is nothing but centimeter. Lambda into 10 power minus 10. This is in joule. Okay, but you want to calculate in electron volt, this is divided with 1.6 into 10 power minus 19 electron volt. This is called 1 electron volt. Actually, electron volt is a unit of energy especially used for fundamental particles like electron, proton and neutron, like that. Okay, what is that? The energy possessed by an electron or a fundamental particle accelerating through 1 volt potential difference is called 1 electron volt. Okay, so while calculating this one, you get 12,400 by lambda in electron volt. Okay, by this way you get this formula. Okay, right. The 15th question. An electron in the ground state of the hydrogen atom has the orbital radius something is given, while that for the electron in the third excited state is given. The ratio of the de Broglie wavelengths of electron in the ground state to that in excited state is. To see, we can picturize, you can easily calculate this question. An electron in the ground state, that means in a hydrogen atom, you know, this is the nucleus of hydrogen atom. Around this nucleus supposed to be electron is revolved in the ground state. Ground state means what? N1. Okay, for ground state. For ground state electron, for ground state, principal quantum number N1 is equal to what? 1. Okay, on this principal quantum number, okay, that means in the first ground state, the radius of the ground state, that means radius of the orbit, that means R1 is given, what is that? 5.3 into 10 power minus 11 meter. While that for the electron in the third excited state, okay, for third excited state, for third excited state. You know what is third excited state? When electron in the second orbit, that is called first excited state. Electron in the third orbit, that is called second excited state. While electron in the fourth orbit, that is called, what is that? Third excited state. So for third excited state, N is equal to what? 4. 4, that means N4 is equal to what? 4. Okay, and its radius is given. What is the radius of the third excited state? R4 is equal to, what is that? 8.48 into 10 power minus 10 meter. So what is the ratio of the de Broglie wavelengths? De Broglie wavelength of an electron in the ground state, say lambda 1. Okay, lambda 1. The wavelength of an electron in the third excited state is say called lambda 4. He is asking, in the given given, what is asking, what is required? Required is equal to what? Lambda 1 by lambda 4. First of all, you know how this de Broglie wavelength related with principal quantum number as well as radius of an orbit. Okay, so from de Broglie concept, from de Broglie hypothesis, you know the matter wave, that means wavelength of a matter wave is lambda is equal to what? Lambda is equal to what? H by P. That means P is equal to momentum. That implies lambda is equal to what? H by mv. You know, this is the de Broglie wavelength, but there is no mass and velocities involved. So you must convert this de Broglie in terms of fundamental unit, principal quantum number and radius. Okay, so for that you can use the postulate. What is that of Bohr? What is that? While electron revolve in its permitted orbit, its angular momentum from angular momentum of electron L is equal to what? mvr is equal to what? nh by 2 pi. That means integral multiplies of h by 2 pi. Okay, from this one, this mv, what is that? This mv is nothing but what is it? Momentum. So this is nothing but p is equal to what? nh by 2 pi into r, isn't it? This r is brought to denominator, so p is equal to what? nh by 2 pi. So substitute in place of mv by nh by 2 pi r. Okay, therefore lambda is equal to what? h by mv. In place of mv you can write this one. What is that? nh by 2 pi r. Okay, that implies lambda is equal to, what is that? Lambda is equal to the h is cancelled, 2 pi r by n. 2 pi r by n. Okay, therefore lambda 4 means what? That implies lambda 1 by lambda 4 is equal to r1 by r4, isn't it? n4 by n1. n4 by n1. So simplified, r1 is equal to what? 5.3. 5.3 into 10 power. That means it may write like this. Power 10 means what? Okay, right. 10 power minus 11 into n4 is equal to what? 4 by r4. r4 is equal to what? 8.48. It may write 10 power 11. 84.8 into 10 power minus 11 into n1 is equal to what? 1. So 10 power minus 11, 10 power minus 11 is cancelled. 4 1 ja, 4 to 1.253. It means 2 1 so 4. That means 1 by 4. Therefore lambda 1 is to lambda 4 equal to what? 1 is to 4. So this is a solution for this question. The 16th question, which of the following circuit represent a forward bias diode? You know diode, forward bias diode. Okay, to see in a PN junction diode, this is a circuit symbol of a PN junction. This is positive and this is what? Negative terminal. Okay, you should connect positive terminal of a battery to the positive end of this diode. Negative terminal of a battery is connected to the negative end of this diode. Then we can say the diode is in forward bias condition. Okay, so you know very well, positive means what? Positive means what? It is related to a high potential. High potential. Negative means what? It is relatively at a low potential. So generally current is always flow from high potential to low potential. This is called conventional current direction. Okay, so according to the given for option A, this is what? Positive, this is negative. You know, this positive terminal is connected to minus 10, negative is 0. So among those two, 0 is more compared to minus 10. So that this is not. So the diode is in reverse bias condition. Next option B, positive end is connected to minus 10, negative end is connected to minus 15. So among those two, minus 10 is more than minus 15. So this is at forward bias condition. Okay, right. Next option C, this positive end is connected to 4 volt. Okay, and this negative end is connected to 2 volt. So this is also at forward bias condition. Next option D, this is minus 5 volt, this is minus 10. But you can see this is positive and this is negative. This positive end is minus 10, this negative end is minus 5. Among those two, minus 5 is more. So it is not in a forward bias condition. Next, coming to the option E, this end, positive end is at 2 volt, negative end is connected to earthing. Earthing means what? 0 volt. So that this is also at a forward bias condition. So this is a multiple option question. So options what? B, C and E are the correct one. Okay, right. The 17th question, a parallel plate capacitor of capacitance 40 microfarad is connected to a 100 volt power supply. Okay, Now the intermediate space between the plates is filled with a dielectric material of dielectric constant K is equal to 2. Due to introduction of dielectric material, the extra charge and the change in the electrostatic energy in the capacitor respectively are. Okay, there are two scenarios are given in this question. First one is called a parallel plate capacitor. First you can take a parallel plate capacitor. This is a parallel plate capacitor, okay, which is connected to a 100 volt, okay, power supply. So first it is connected to a 100 volt power supply, okay. Its capacitance is given, okay, C is equal to what, 40 microfarad, given C is equal to what, 40 microfarad, okay, which is connected to a power supply of potential how much, 100 volt, okay. Then what happen, some charges accumulate on the capacitor plates, okay, which is equal to Q, which is equal to what, Q, okay. Now from definition of capacitance, C is equal to what, Q by V, that implies Q is equal to what, C into V, okay. This is the condition, first scenario. Next what happened, now the intermediate space between the plates is filled with a dielectric material. Now the space between the capacitor plates is filled with a dielectric material. Now the same capacitor, okay, which is connected to a cell of 100 volt, okay, is now filled with dielectric material, which is filled with the dielectric material of dielectric constant, what is that, K is equal to what, 2. Now what happened, capacitance is changed, how much, how to change, K is equal to K times of its capacitance, initial capacitance C, okay. Similarly potential, there is no change in potential, that means V dash is equal to what, V only, okay. Now capacity, that means charge may be change, the charge may be what, change, okay, from Q to Q dash, from Q to what, Q dash, okay. So from same definition, capacitance C dash is equal to what, Q dash by V dash, isn't it? That implies Q dash is equal to what, C dash V dash. What is first is asking, due to introduction of dielectric material, the extra charge, what is that, the first one is called the extra charge, the extra charge delta Q, what is Q dash minus Q. When you subtract a charge accumulate after introducing the dielectric material from, okay, from capacitor without dielectric, when you subtract these two, then you get the extra charge accumulate on the capacitor plates, which is equal to delta Q dash, delta Q is equal to Q dash minus Q. You know Q dash is equal to what, C dash V dash, Q is equal to what, C into V. You know one thing, what is the consequences while introducing a dielectric material between the space of a capacitor plates? Its capacitance is increased by dielectric constant times. That means C dash is equal to what, Kc into V dash is equal to what, V. That means second consequence is what, there is no change in the potential of the capacitor plates. That means C dash V dash is equal to V minus C into V. Therefore when you from this one I would like to take Cv becomes common, K minus 1. Already C is given, C is equal to 40 microfarad. 40 microfarad means 40 into 10 power minus 6. Okay, micro means 10 power minus 6 into potential 100. 100 equal to what? 10 square. Into K is equal to what? Dielectric constant 2. 2 minus 1. So you can write 400. Isn't it? 4 1. That means 400. Sorry, 4000. So which is equal to what? 4 microcoulomb. 4 millicoulomb. Okay, isn't it or not? 10 power 2. Okay, right. Okay, right. Next, this is the first one. Next, second one is asking, what is that? And change in the electrostatic energy. You know, without introducing the electric energy, E is equal to what? Half C into V square. Half into what? C into V square. After introducing the electric energy, E dash is equal to half C dash V dash square. Half C dash V dash square. Or next one is the change in electric. That means second one, the change in energy. The change in energy. What is that? Delta E is equal to what? E dash minus E. Therefore, delta E is equal to E dash means what? Of C dash means what? C dash is equal to CV, sir, K into C. Okay, into V dash means what? V square. Next, E is equal to what? Of CV square. Of CV square. So from this one I would like to take off into what I would like to take half CV square taken as common, K minus 1. Therefore, delta E is equal to half into C. C is equal to what? 40 micro. That means 40 into 10 power minus 6. V square means V is equal to 100 means 10 power 4. V square means 10 power 4 into 2 minus 1. So 2 1 ja, 2 20 ja. So value calculating 20 into 10 power minus equal to what? 0.2 joule. So the answer for this question is what? Change in the extra charge delta Q is equal to what? 4 millicoulomb, and delta E is equal to what? 0.2 joule. Okay, right. Right. 18th question. An electron is made to enter symmetrically between two parallel and equally but oppositely charged metal plates, each of 10 centimeter length. Okay. The electron emerges out of the field region with a horizontal component of velocity 10 power 6 meter per second. If the magnitude of the electric between the plates is 9.1 volt per centimeter, then the vertical component of velocity of the electron is. To see, this may be simplified like this. An electron is made to enter symmetrically between two parallel and equally but oppositely charged metal plates. Suppose this is a first metal plate. Okay, this is another metal plate. This is positively charged. Okay, this is negatively charged. Okay, this is the first statement. An electron is made to enter. That means into this electric field, okay, electron emerges out. That means electron emerges out with a velocity of horizontal velocity of what? 10 power 6 meter per second. 10 power 6 meter per second is given. But actually, when electron is accelerating through this electric field, due to positively charged metal plate, it is deviate from its actual path like this. It is deviate like this fashion. So he is asking what is the vertical component of velocity. Okay, so at this point when it emerges out, the velocity is resolved into two components. One is called Vx, one is called Vy. Isn't it? Okay, right. So what is the length of the each metal plate? 10 centimeter. So here the electron is traveling through a plane, xy plane. So it covers equal distance in same time. That means it covers some distance horizontal as well as vertical in same time. So first of all, you can calculate what is the time taken to cover this 10 centimeter, okay, for emerging out in between the metal plates. So time taken by the electron, okay, to emerging out of metal plates, emerging out from the metal plates, T is equal to what? X by V, displacement by velocity. What is the displacement? 10 centimeter is supposed to be covered. It means what? 0.1 meter by velocity 10 power 6 equal to what? 10 power minus 7 second. So the electron is taken 10 power minus 7 second to emerges out from these 10 centimeter length two oppositely charged metal plates. Okay, so when it is moving, what happens? Accelerate. So acceleration of the particle, acceleration of an electron A is equal to what? From Newton's law, F by m. Here F is equal to what? Force. What kind of force? Electric field exerts some force on this charged electron, which is equal to electric field intensity at that point. That means F is equal to what? EQ by m. Therefore, A is equal to what? E. E is the intensity of electric field. Already it is given. The plates are in between the plates. This amount of electric field is set up. That means A is equal to E. E means what? 9.1 volt per centimeter means what? 9.1 into 10 power minus 2 volt per meter. Okay, into charge of the electron 1.6 into 10 power minus 19 coulomb by mass of the electron is given. What is that? 9.1 into 10 power minus 31. This 9.1 is cancelled. Then you get 10 power minus 2, 10 power minus 9, 10 power minus 21 plus 31. 10 power, 1.6 already there. That means 1.6 into 10 power, what is that? Plus 10. This is the meter per second square. This is acceleration. Now you want to calculate, what is asking? Then the vertical component of velocity, you know, velocity component, vertical velocity component. Okay, Vy is equal to, okay, Uy. Initial velocity component along the y-axis plus acceleration along the y-axis plus time taken. Okay, therefore Vy is equal to Uy. What is the Uy? Body is, that means electron is coming out horizontally. That means vertical component of velocity initially is equal to 0. Okay, plus Ay. Ay is equal to what? 1.6 into 10 power 10 into, okay, time taken. What is the 10 power? Minus 7. Okay, equal to what? 1, that means 1.6 into 10 power 3. That means 16 into 10 power 4. Sorry, 10 power 6. 10 power 6. Okay, meter per second. This is the solution. Okay, right. The 19th question, which of the following resistivity rho versus temperature T curve is most suitable to be used in wire bound standard resistor? What is it? Wire bound standard resistor. Okay, to see, first of all, what is resistivity? You know, what is resistivity? From definition of resistance R is equal to rho into L by A. Here rho is called, what I say, resistivity, or here rho is called what? Resistivity, or what is the specific resistance, so rho is equal to what? Ra by L. You know, in this equation, in this question, if A is equal to what? 1 meter square, L is equal to what? 1 meter. Therefore, resistivity equal to what? Resistance. That means resistivity or specific resistance of a conductor material is resistance of that conductor material having unit cross section area and unit length. This is called, what I say, specific resistance or resistivity. Okay, experiments are reveals that the resistivity of a material is found to be dependent on the temperature. That means different materials do not exhibit the same dependence of temperature. Okay, so how dependent resistivity with temperature? Rho T is equal to rho naught into 1 plus alpha into delta T. 1 plus alpha into what? Delta T. Okay, here rho T is the resistivity at temperature T, rho naught is the resistivity at some temperature, initial temperature, alpha is the coefficient of resistivity of that material. Okay, so when you plot a graph between rho T and rho naught, we get an equation is like this. Why? Because here to see, already I told you, what is that? The resistivity of a material is found to be dependent on temperature. Different materials do not exhibit the same dependence of temperatures. Okay, so here what is this? Wire bound standard resistor. Here to see, standard resistors are the resistors, their resistivity or specific resistance does not change with temperature, but exactly it is not followed by any material, but alloys like nichrome, okay, nichrome, manganese, okay, these kind of materials are doesn't change their resistivity, okay, with temperature. Okay, so among those, this is the suitable. Supposed to say this is actually not same, That means it is also not constant resistivity to the temperature, but compared to remaining, drastically change doesn't appear here. So that when you draw a plot graph between resistivity of a standard resistors and temperature, it appeared like this. Okay, so that, okay, this is the correct option for this question. Okay, right. The 28th question, a line charge of length a by 2 is kept at the center of an edge BC of a cube a, b, c, d, e, f, g, h having edge length is a, as shown in the figure. Okay, to see, this is a cube a, b, c, d, e, f, g, h. Okay, what is given? A line charge of length. Suppose a line charge of length is equal to what? A by 2 is at the center of a one of the side of this cube, whose side is equal to what? A. Okay, if the density of line is lambda c per unit length, okay, the density of charge of line charge, what is that? Lambda c per unit length. Then the total electric flux through the all the faces of the cube will be. This is asking. Okay, this question may be done based on Gauss law. What is Gauss law? Gauss law states that the total electric flux. What is the total electric flux through any closed surface? The total electric flux through any closed surface is equal to epsilon naught times, that means 1 by epsilon naught times of net charge enclosed by that surface. Net charge enclosed by that closed surface. This is called the Gauss law. Okay, here to see, this is a line charge. You know, L length of okay side having charge is equal to what? Is equal to what? Q amount of charge. Okay, here unit length is equal to what? Unit length is equal to Q by L amount of charge. This is called linear charge density, say called lambda. Okay, but here a line charge of length is equal to what? A by 2 is given. That means L is equal to here given L is equal to what? A by 2. So therefore linear charge density lambda is equal to what? Q by A by 2, which is equal to what? 2Q by A. That implies the charge enclosed by the surface Q is equal to what? Lambda A by 2. Okay, you know, you want to calculate total electric flux, you must be imagine a Gaussian surface. That surface must be enclosed by this charge, linear charge density. So you want to enclose, that means you can complete it. You have to imagine 3 more. What is that? 3 more cubes which are enclosed. That means at its center, okay, the linear charge is supposed to be there. So those 4 sides of that remaining 3, including this one is called 4, is share the total electric flux. So net flux through the closed surface, say called phi is equal to what? Q by epsilon naught by 4. Q by epsilon naught by 4. So Q is equal to what? Lambda A by 2 by epsilon naught by 4, which is equal to what? Lambda A by 8 epsilon naught. So this is the total electric flux, okay, through all the faces of the cube. Okay, that's it. The 21st question, there are two statements are given. The first statement is the equivalent EMF of 2 non-identical batteries connected in parallel is smaller than either of the 2 cells. To see the equivalent EMF of 2 non-identical batteries connected in parallel. So there are 2 batteries. This is the first battery whose EMF is E1, internal resistance is R1. This is the second battery whose EMF is E2, internal resistance is what? R2. These are the characteristics of a, okay, what is that? EMF and internal resistance, both are the characteristics of a cell. Okay, so what happened? Generally the currents, okay, starts from positive terminal from first cell, current I1, current I2 from second cell is drawn. Both are combined at this junction, say called B1. Okay, they are make I. Okay, this end is called A, for example A. Okay, later what happened? The same current is enter by means of current I2 and I1 into the negative terminal. Okay, so what happened? the potential drop across this end is, this junction is B1, this junction is what? B2. So what happened? The PD, that means the potential difference across first cell is equal to E1 minus I1 R1, isn't it? Why? Because from this cell current is drawn, so its EMF is dropped. So similarly, the PD across second cell, what is that? E2 minus I2 R2. Okay, actually, but both are, first cell and second cell both are connected across the same two terminals, so that potential drop across B1, that means B1 minus B2, is same for both the cells, isn't it? But here to see, and this is equation 1 and this is equation 2, and moreover at B1, at junction B1, at B1, what happened? Current I, total current I is equal to what? I1 plus I2. What is that? I is equal to what? I1 plus I2. Okay, now combine these two. Therefore, but current I1 is equal to what? I1 is equal to E1 minus V by R1, isn't it? EMF minus potential drop, me by R1 through the current of the first cell. Similarly, E2 minus V by R2 is the current through the second cell. When you simplify it, E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. It may be read like this: E1 by R1 plus E2 by R2 minus V taken as common, V into 1 by R1 plus 1 by R2. Isn't it? This is the total current. Okay, so hence V is written as, that means here V is written as, how you can write it? Written as V is equal to, what is that? E1 R2 plus E2 R1 by E1 R2 plus E2 R1 by R1 plus R2, isn't it? R1 plus R2 minus current I into 1 by R1 plus 1 by R2. You know, this total resultant may be replaced by a single cell. This is the E equivalent. Similarly, R equivalent, the current is drawn from it. Okay, like this. So from this one you can write E equivalent. E equivalent, what is that? E1 R2 plus E2 R1 by R1 plus R2, and R equivalent R1 R2 by R1 plus R2. That means both are reciprocal. So from this we come to one conclusion: the resultant EMF must be greater than any one of the individual of the EMFs. So the first statement is, what is given statement 1? The equivalent EMF of two non-identical batteries connected in parallel is smaller. It is not smaller, it is more than any one of the individual. So this statement is what? Wrong. The statement is what? The equivalent internal resistances of two non-identical batteries connected in parallel is smaller than, isn't it? It is correct. Why? Because the equivalent resistance equal to what? Parallel. That means R1 and R2 both are parallel. So in parallel combination of resistors, what? 1 by R equivalent equal to what? 1 by R1 plus 1 by R2. That means resultant resistance, internal resistance, is less than any one of the individual. Okay, so this statement is correct. Okay, that's it. 22nd question, assertion reason question. Assertion is given. What is that? If Young's double slit experiment is performed in an optically denser medium than air, then the consecutive fringes comes to closer. Okay, to see. If Young's double slit experiment, okay, performed in an optically denser medium, okay, then air, the consecutive fringes, you know, consecutive fringes is nothing but what is a fringe width. That means the distance between successive, okay, fringes is nothing but fringe width is represented by beta is equal to what? Lambda d by d, isn't it? Now this is the fringe width while you perform the Young's double slit experiment in air. Now you can say, you can do the same Young's double slit experiment in any optically denser medium. What happened? in denser medium, light suffer, okay, change in speed, so that its direction is changes. That means this optical denser medium opposes for easy flow of light, so that what happened, wavelength is changes. In denser medium, what happened, the distance traveled by the, that means the wavelength, that means distance traveled by the light in optical denser medium is, okay, is decreases. Is what? Decreases. That means what? Decreases. Then automatically fringe width what? Fringe width was also decreases. Why? Because from this equation you can write fringe width is directly proportional to wavelength. If wavelength is decreases, fringe width is also decreases. So assertion is correct. Okay, next reason. What is that? The speed of light reduces in optically denser medium than air while frequency does not change. Why? You can see it. You know, the refractive index of a medium is always inversely proportional to speed of light in that medium. Okay, more the refractive index means more the denser medium that is. So more the refractive index, less the speed. That implies mu is equal to C by V, isn't it? Here C is the speed of light in air, isn't it? So here V is equal to, therefore that means speed of light in any medium is equal to what? C by mu, isn't it? C by mu, or simply say, not required here to say. So you know, C is equal to what? Speed of light in air. You know, from relation between speed and frequency, C is equal to what? N into, that means frequency into wavelength. Frequency to what? Wavelength. That means C is equal to what? Speed of light in air is equal to frequency of light into wavelength of light in air. Similarly, V is equal to what? F into lambda in medium, because V is the speed of light in a given any other medium, that means denser medium. So you can replace C by F into lambda in air by V is equal to what? F into lambda in medium. Lambda cancel. Why? Because the speed of light reduces in an optical denser medium than air while the frequency does not change. Frequency remains same. That means which is equal to what? Lambda air by lambda medium. So you can write that implies lambda medium is equal to what? Lambda air by mu, refractive index. So there is no speed term is involved here. So reason is not the correct, okay, explanation of assertion. So A is true, but R is not true. It means it is a false, isn't it? Like that's it. The 23rd question, in the diagram given below, okay, this is the diagram. There are three lenses formed. To see, this is the first lens, this is the second lens, and this is the third lens. Okay, considering negligible thickness of each of them as compared to R1 and R2, that is equal to the radii of curvature for upper and lower surfaces. That means this is the upper surface and this is the lower surface. This radius of curvature is negligible. Okay. Glassless, the power of the combination is. So what is the power of the combination of these three lenses formed by, okay, this diagram? Okay, to see the first diagram, to see this is the upper surface, this is the lower surface. Okay, so this is the first one, isn't it? So this is what its radius of curvature, R is equal to what? Infinity. The lower surface is equal to what? R1. This is R1, this is R2. Here R2 is equal to R1, remember. So that is categorically mentioned in this question. So the power of the lens. The power of the lens. Okay, which is obtained from lens maker's formula. P is equal to what? 1 by F is equal to what? Mu minus 1 into 1 by R1 minus 1 by R2. According to this one, power P1, power of the first lens, say P1 is equal to what? Mu. What is the refractive index of the first water lens? 4 by 3. That means 4 by 3 minus 1 into 1 by R1 means what? R1 equal to what? Alpha. That means infinity. Okay. Minus 1 by R2 means what? R1. But this is the radius of curvature. You can take below the reference axis, so that it is nothing but what I say? minus R1. Therefore, P1 is equal to 4 minus 3, 1 by 3. That means 1 by 3 into what? Minus minus plus. That means 1 by 3 R1. This is 1. Okay, next. This is the second lens. This is the second lens. This is a second lens. So this is equal to what? R1. This is equal to what? Radius of glass is equal to what? R2. So the power of the lens. The power of the second lens. The power of the second lens. Power of the second lens. Say P2 is equal to what? Same formula. 1 by F is equal to what? Mu. What is the refract index of this glass lens? Second lens. 3 by 2. That means 3 by 2 minus 1 into 1 by R1 means what? 1 by R1. 1 by what? R1. That means 1 by minus R1, which is also below the reference axis. So that 1 by R1 minus 1 by R2. It is equal to what? R2. Okay, it is also below the reference line. So according to sign convention, it equal to what? Minus R2. Minus R2. Therefore, P2 is equal to what? 3 minus 2. That means 1 by 2. That means 1 by 2 of 1 by R2 minus 1 by R1. So minus minus plus, so it is brought to first, then minus R2, R1 taken as to is next to minus 1 by R1. Okay, so this is 2. Next, third lens. This is the third lens. What is the third lens? To see. This is the third lens. Okay, this is the third lens. This thing. So the power of this lens. The power of the third lens. What is that? P3 is equal to same. Mu minus 1 into 1 by R1 minus 1 by R2. So this is equal to what? R2. This is equal to what? Infinity. Its radius of curvature is equal to what? Infinity. So P3 is equal to what? Its refract index. What is that? Again water. That means mu is equal to what? 4 by 3 minus 1 into 1 by R1. That means what? R2. It is also below the reference line. So it is equal to what? Minus R2 reference line according to sign convention minus 1 by infinity. Therefore, P3 is equal to what? 4 minus 1. 4 minus 3. That means 1 by 3. 1 by 3 of minus 1 by 3 R2. 1 by minus 3 R2. Okay, right. Therefore, okay, what is asking? The power of the combination. Therefore, power of the combination P is equal to what? P1 plus P2 plus P3, which is equal to P1 is given. What is that? What is getting? 1 by 3 R1 plus P2 is equal to what? P2 is equal to 1 by R2 minus 1 by 2 R1 minus 1 by 3 R2. Isn't it? So from this one 3 R1, 2 R1. Okay, that implies power P is equal to what? You can take 1 by 6 as common. 1 by 6 as common. You can get 1 by R1. 1 by R1. 1 by R1 minus 1 by R1 which is equal to minus taken as minus is common. Minus 1 by 6 is taken as common, which is very easy to us. So P is equal to 1 minus 1 by 6, what? 1 by R1. Here also this is R2. Where is R2? This thing. Okay, so 1 by R1 P2, 1 second you can check it. P2 is equal to 1 by 3 or 1 by 3 R2. P1 is that thing. Okay, right. 1 by R1 minus 1 by R2 minus 1 by what? 1 by R2. So this is the power of the combination of these lens. Okay, right.